Hello everyone, thank you for coming back to my channel. Previously, we have discussed about grabs and we have talked about the first 5 of grabs patterns. In this video, we'll talk about the rest of the grabs patterns. As previously, this is a beginner level topic and you only need to have a bit of knowledge in a language with an object-oriented programming feature like Java. The rest of the pattern that we will talk are controller, polymorphism, indirection, and protected variation. The first pattern that we'll discuss is controller. So controller acts like a facade from the UI layer. We can see on the first picture a class that handles a button click event delegated to sales controller, while on the right side we can see that the event handler contains business logic, and that's not what we want. We want the class to be cohesive. We want it to be minimized, to have small size, to do one thing. So the left side is more appropriate design because it delegates to sales controller, and the sales controller probably will delegate to other collaborating classes like repository or something like that. Now there is a confusion here. You might have heard of MVC or model view controller. Now the controller in grabs is not the control in MVC. The controller in MVC is part of the UI layer. That's not the case with the controller in grabs. In grabs it acts like as a facade, as a delegation from the UI layer. So they are two different controllers. Please keep that in mind. The next pattern that we will discuss is polymorphism. Polymorphism deals with how to handle alternative byte types and create a pluggable software component. We can see the example there. A base class of shape has two subclasses, rectangle and circle, and they override the get area function. And we can see the wrong design on the left side. You can see the wrong code. We check the type like that, and the disadvantage of this approach is whenever we add a new subclass of shape, we need to modify the code, and that's not a good design. There is a pattern called open-close principle in the solid principles, but we'll talk about it later. For now, keep that in mind that we should not check for the type of a subclass. Instead, use polymorphism so that we don't need to modify the code if you add a new class. The next pattern is indirection. You can see in the example that the business service class uses the third-party email sender at the bottom picture. At the top, the third-party email sender class is encapsulated by the email sender. It's called an indirection. So the motivation is, first is reusability. By encapsulating and prevent direct access, sometimes we can achieve reusability. Let's say that we have a complex API to access a database, and we encapsulate all of them in a repository, and the other classes can use that repository instead of direct coupling to the complex database API. So it promotes reusability because the logic is only met once in that repository class. And the second motivation is a consistent interface. In this example, let's assume that the third-party email sender has unstable interface. We encapsulate it in email sender because we don't want to change the business service class too much. Let's say that it contains important business logic. We don't want to modify it that often. So we give it a stable interface, the email sender. So if the third-party email sender changes in the public interface, only the email sender class needs to change. But the business service can remain as it is. This is the reusability factor that we previously talked about. Let's say that both sales service and purchase service need to use some kind of product related logic, and on the left side it's encapsulated in product service, so it's reusable, while on the right side both of them contain duplicated code. You can see that indirection can promote reusability. This is the last pattern that we'll discuss. It's called the protected variations. Protected variation minimizes the impact of a particular change to the whole system. What we need to do is to create a stable interface to wrap the unstable part and let other part of the system to use that stable interface. So it's like an indirection, but it's with the focus of protecting a particular component from an instability. It's one of the motivation of indirection. Let's take an example of the property file that we use often. We sometimes externalize a particular values in the property files when we make an application so that we can change it easily. The code don't depend on the values directly, but it depends on the property keys on that properties file. So we don't need to recompile the code whenever there's a change. We only need to change the property file. That's one of the examples, but there are still a lot of other examples. So we have reached the end of the video. Thank you for watching this video, and in the next video we will talk about the solid patterns or principles. Thank you for watching.